Now we are going to talk about symmetry in graphs of equation in two variable. Symmetry. So let's talk about the general concept of symmetry. Let's say you have a graph. Well, don't like that line. Let's say you have don't like the line either. All right. Okay. All right. I mean that's a little better. Let's say you have this y-axis and x-axis. All right, now let's say you have graph that looks like this. Looks like this. Well, you got the idea, right? And let's assume that this is actually a perfect graph, that the left side and right side looks exactly the same. Well, left side and right sides are exactly the same with respect to what? With respect to the y-axis, this line in the middle, right? So if our graph looks like this, then we say this is symmetric with respect to y-axis, right? So this is called to the y-axis. All right, so, well, let's talk a little bit more about symmetry with respect to y-axis. So what does that supposed to mean? Let's say you have this point right here. Let's say the corresponding x value is 3. Then if this graph is symmetric with respect to y-axis, then you must, and let's say this is 2. Then if it's symmetric with respect to y-axis, then you must have this point right here where the corresponding x value must be. It must be what? If it's symmetric with respect to y-axis, it must be. That's right, it's -3. And y value is still the same. So if it's symmetric with respect to y-axis, if you have x, y point, then let's see. Then you also must have, let me just readjust a little bit. You also must have, if you have 3, you have to have -3, right? If you have x, then you must have -x. What about the y value? Did y value change? If it was 2, was it -2? No, it was still 2. Y value didn't change. So y value is just a y. But x value must be -x. So if you have x and y, you must have -x and y as well. If this graph is symmetric with respect to y-axis, right? Y-axis. All right. Now let's talk about another graph. Let's say we have graph looks like this. Now this time graph looks like this. Right? Graph looks like this. I mean, let's pretend that this is actually a perfect looking graph, right? And let's say you have this point right here. Now, as you can see, this graph is symmetric with respect to x-axis, right? Which means if you fold it along with this axis, right, x-axis, this part is going to be on top of each other, right? It'll be fold right on top of this. So this would be symmetric with to the x-axis. Right? This is symmetry with respect to the x-axis. Well, so let's say this point right here is 3, and this point right here is 2. If this graph is symmetric with respect to the x-axis, then we must have this point which shares the same x value, but this y value must be what? This y value must be negative 2. So in other words, if we have x and y, if it's symmetric with respect to the x-axis, then we must have same x but negative y. Right? Same x but negative y. That's symmetric with respect to the x-axis, right? That describe symmetric with respect to the x-axis. All right. Now, the last one is symmetric with respect to the origin. So let's say you have this graph, right? And your graph now looks like this. Again, I mean, let's assume that this is nice, perfect, smooth curve that goes like this, right? And let's say this point right here, oh, change color, right here. Let's say that's 2, and let's say this is 1. This is x, and this is y. Now, as you can see, this is origin right in the middle, right? So if you fold along with x-axis and fold again along with y-axis, then these two lines are going to be on top of each other. So if the graph looks like this, then we say it's going to be symmetric with respect to the not x-axis, but not y-axis, but in this case origin, right? Symmetric with respect to the origin. So if you have 2 and 1, you must have this point here as well, where the x value must be negative 2, y value must be negative 1. So if you have like xy on that graph, then now you have to have negative x and negative y, right? That's symmetric with respect to the origin. So if we go back and review it, let's say if it's a symmetric with respect to the y-axis, then xy goes to negative x and y, right? That's y-axis. If it's symmetric with respect to the x-axis, then xy goes to x negative y. If it's to origin, then both x and y goes to negative x and negative y. Okay, so let's check out an example. Right, let's check out an example. So let's say example. test y equal x squared plus 3 for symmetry. Right? Test this. Okay. So let's test, let's say x-axis first. Right? Symmetry for x-axis. Now, symmetry with respect to x-axis was what? If you have x and y, then you should have x and negative y, right? So to test this, you replace y to negative y and see if you have the exact same original equation, right? See if you have exact same original equation. So we have y, this y becomes negative y equal x squared plus 3, right? Y equal x squared plus 3. Now, and what we are doing, compare this with what? With the original equation. Is this the same? Of course it's not the same because we have this negative. What does that mean? That means this graph is not symmetric. With respect to x-axis. Right? It's not symmetric with respect to x-axis. All right, let's check out y-axis. Y-axis was what? xy goes to negative x and y. So what was our original equation? Our original equation looks like this, right? Let's say, so what we are going to do, we're going to replace, x now to negative x. That's what happened here. What about y? Y is just a y, so there's nothing to change for y, right? Just the x replaced to negative x. So the original equation, let me write the original equation looks like this, right? X, y equal x to the third, x to the square plus 3, right? Now this becomes, only we change x to negative x, so y equal, now this x, now we're going to change to negative x, right? So negative x square plus 3. Well, what's negative x square? Well, negative x square is same thing as just x square. And check this out. Is this same as the original equation? Yes. This is the same as the original equation. So yes, symmetric with respect to y-axis, right? Symmetric with respect to y-axis. All right, now let's check origin. Now, symmetric with respect to the origin, what do we have to change? x and y is going to be replaced to negative x and negative y. So the original equation y equal x2 squared plus 3 now becomes negative y equal negative x squared plus 3, which is what? Which is negative y equal x squared plus 3. Is this the same? Is this the same? Not the same. Not the same. So, not symmetric. With respect to the origin. Right? Not symmetric with respect to the origin. So, this symmetry, all you really need to do is just, depends on what you are testing. If you're testing for symmetric with respect to x-axis, you change y to negative y. And if you check symmetric with respect to the y-axis, right, the y-axis, then you change x to negative x, right, replace x to negative x. See if it's same as the original. If you are checking symmetric with respect to the origin, then you both change x and y to negative x and negative y, right? Negative x and negative y. Okay. Now, let me give you one more example, right? One more example. Square plus 1 for symmetry. Okay, so, as I told you before, why don't you pause this video and try it for yourself, by looking at your note and try it for yourself, and why don't you check the answer with me, right? So, all right. So let's say you tried it, and let's check out the answer together. So we're going to test for x-axis. Right, x-axis was what? X, y goes to x negative y, right? Meaning you only change y. And if you change y, then the original equation, right, that y equals to negative y, and the rest, no change. And of course, this is different from the original. So, not symmetry. With respect to x-axis. Excuse me. So, just to clarify, why did I say these are not the same? Because, of course, this one has just y here. This one has negative y, that's what we changed. And they are not the same because this one has negative there, right? Okay. Now, let's check symmetric with respect to y-axis. So what do we need to change? X and y goes to negative x and y. You can kind of see that this one has x squared there, x squared there. So even if we change that x to negative x, because of that square, then negative will cancel out. We end up getting the same answer, right? That's the deal. So, well, let's do it anyway. So this would be y equal 4 negative x squared over negative x squared plus 1. Now, if we simplify this a little bit further, this would be y equal 4x squared and x squared plus 1. Now, let's check this. This is exactly same as the original equation, right? So, this is, yes, symmetric. With respect to the y-axis. Okay. Now, lastly, origin. Now, to test symmetry with respect to the origin, x and y goes to negative x, negative y. So, our original equation now become negative y equal 4 negative x squared negative x squared plus 1. And this will be negative y for x squared plus 1. Just like that. Okay. So if that's the case, this is not the same thing as the original. So not symmetric with respect to the origin. Right? Not because of this minus. Right? Okay.